Hey guys, today we're going to be talking about HR diagrams or Hertzsprung-Russell diagrams. If you have colors, matte pencils or markers, today would probably be a great time to use them. If you don't, it's not the end of the world. But we're going to be doing some graphing and it does involve some colors. So when we're looking at stars, we've just studied the life cycle of a star. And we were discussing how to classify stars, which is generally by size and temperature. When we look at an HR diagram, we are going to classify stars in those same two ways, plus an additional way. We have an additional information. So we're going to write in that there are 3 ways to classify. On an HR. Okay, so size is one of the ways that we've already talked about, but when we're actually looking at HR, it's the least important. We're going to have temperature. And when we're talking about stars, it's generally not in Celsius. We're generally going to use something called Kelvin, Kelvin, and we'll symbolize that with a K. It'll look like this. And luminosity. Lumen means to be lit or to be bright. So luminosity is just a really fancy word for brightness. Another really fancy word for brightness or luminosity is this word magnitude. So when we're looking at stars, these are really your big focuses. Now we're going to draw a really tiny graph. It's not going to be ginormous. We're going to use about 5 lines. And so I want you to come down. 1, 2, 3, 4, 5. And I want you to come all the way over. All right. So when we're talking about temperature and luminosity, those are going to be our 2 axes. Temperature is going to be down here on the bottom. So if you will write temperature here, leave yourself some space. And again, this is going to be in Kelvin. There is something that's super strange about temperature on these graphs. And it's actually that it goes backwards. Our temperature actually starts from the coldest to the hottest over here. So when we're looking at that temperature, we're going to start at some of the coldest temperature for stars, which are going to be about 2,500 degrees Kelvin. And we're going to get to some of our hottest stars, which are going to be over here, and they are going to be around 40,000 Kelvin. Okay. When we look at these, stars are often going to be based on some colors. So we're going to have our 25, our reds over here, and our hottest, about 40,000, sometimes even more, over here, and they're going to be these bright, bright, bright blue. And so the colors are going to range going across. So we're going to have red stars that are going to be here. We're going to have some orange stars. And these are really considered our coolest stars. We are also going to have some yellow stars, like our sun. And then we get into this big chunk of white. Now, obviously, I can't write in white, so I'm going to write the word white. These are going to be your stars that are going to be white. Typically, those are stars that are 20,000 degrees or higher. All right, so when we look at these, they're often going to be reflected somewhere in some color. Some HR diagrams will actually be colored, And some HR diagrams just place the stars on this diagram in the color that's necessary. All right, our other axes, so this is temperature, and again, if you want to write this, is going to be backwards. This is the weirdest thing about this graph, is again, these are going to be backwards, is going to be turning this way. This direction is luminosity. And I'm going to say brightness a lot, but again, it's really just to make sure that you're understanding that luminosity and brightness are the same. I will always write the word luminosity instead of brightness because I want you to get that word very well embedded into your head. And so it's pretty important. When we're talking about luminosity or brightness, we're always going to refer to our star. So if you want to go about halfway, and I want you to put a 1. Our star is considered 1 luminosity or 1 lumen. When we're talking about our stars and suns, we're always going to refer to it's either hotter or colder, brighter or dimmer than our sun. So in this case, as we go up, these stars are going to be brighter. So these stars might be 1,000 times brighter. And these stars might be 100,000 times brighter. Okay. Coming the other direction, these stars are actually going to be less bright than our sun. Think of the word dim, D-I-M. So these stars might be 0.001, which is 1,000th of the brightness of our sun. The next might be 0.00001, which would be 100,000ths less bright than our sun. So think of these as inverse numbers. Okay, so when we're looking at this, let's place our sun on this diagram. So our sun sits at approximately 6,000 degrees. It's like 5'8" and some change, but we're going to say about 6,000 degrees. And our luminosity of our sun, as we discussed earlier, is 1. So if you want to take your 1, you're going to come across, and you're going to line it up with your 6,000. This is about where our sun lays. Okay, so our sun is considered the average. Everything is more or less than our sun. So if you want to write here that this is considered an average brightness and an average temperature. Okay. When we're looking at our stars here, notice these were 2,500 degrees, whereas these are 40,000. So relatively speaking, 2,000 is cool. So these are going to be cool stars in this chunk. Think of this as splitting your diagram into 4 quadrants. This quadrant is going to be cool and less bright than our sun. So the word for that is dim. This quadrant up here is still cool because it's still at 2,500 degrees, but its brightness is 100,000 times brighter. So these are going to be cool and bright. This chunk down here, on the other hand, these are very, 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 very hot. So we're going to think of this section as hot, but it's less bright than our sun, so it's hot and dim. And this section here will be 40,000 is hot, and 100,000 times is bright, brighter than our sun. So when we look at stars, again, we're always going to be looking at this comparison. So we've got our hot dims, our cool brights, and our hot brights. So we'll refer to those, temperature and size, or temperature and luminosity. Next, we're going to look at a graph based on size. So again, we're going to draw a graph, and you can use this whole rest of your paper for this graph. I'm going to come all the way across. Again, I'm going to put this in temperature in Kelvin, and I'm going to do this in luminosity. On the side. All right, so we're going to have our temperature and our luminosity. Another way, instead of writing all of the zeros that we wrote above, is to write them as 1. And this would be like 10 to the negative 2. That'd be 100. And this would be 10 to the negative 4, and this might be 10 to the negative 6. This side, we're going to do the same thing. This would be 10 to the 2, the second power. This might be 10 to the 4th power, and this might be 10 to the 6th power. Okay. We're going to do our same thing with our temperatures. We're going to say this is about 40,000. I'm going to say this next chunk is about 20,000. And then we do a big jump down to about 10,000. And then we're going to do a chunk here at about 6,000. And we'll do a chunk about 4,000. And a chunk of 2,500. Okay, so we're going to have a couple of different temperatures. When we're looking at these, again, we're always going to be in reference to our sun. So if we want to put our sun first, anytime you have a diagram, I recommend you putting your sun first. Star questions almost always reference our sun comparing things. So we're going to come to the 1 and about the 6,000, which is about right about here. And we're going to say this, again, is our sun. If you can remember from our previous life cycle questions, the sun is considered a main sequence star. 90% of the stars in this category belong in this category. So this one's kind of interesting. This is the funky category. So we're going to start about 2,000, and we're going to do a big old S. We're going to kind of come up and up like this. This whole chunk are considered main sequence. And I'm going to kind of just continue this chunk up like that. Okay. This whole chunk following this line, these are all going to be considered main sequence stars. And again, I'm going to point out that 90% of the stars in the universe are in this section. I'm just going to put R here. In the main sequence stars. All right, so they become main sequence. Again, those are small to medium-sized stars, and they are going to gain or lose value here. All right, then your next category would be your giants. So your giants are going to go here. As we discussed before, giants can be red. That's an A, I'm so sorry. Giants can be red, giants can be orange. Every once in a while you might even get a giant that's yellow, but usually you're going to be in that red-orange chunk. So these are going to be our giants. Coming all the way across the top, these are going to be our supergiants. And again, their color is going to be based on where they're at. So if they're down here, they might be a red giant. If they're over here in the 4,000, they might be an orange giant. If they're all the way over here in 20,000, they might be white giants. But these are your supergiant categories. Remember, once they've blown all of their, your giants have at least, blown off all of their energy, you're going to come down to this section. They become very, very, very hot but they become less bright. This chunk down here is going to be our white dwarfs. But they don't stay in this category forever. They've burned off all their gas. They're basically glowing hot embers of coal, and they're losing energy very quickly. So the coal can be very, very hot, but it is not bright. And that is it for your notes. We're going to jump into placing these as your next activity.